Good morning, everyone. First of all, I would like to thank our respected guide, Dr. Shweta Devdas ma'am, for her continuous support and guidance throughout his presentation and preparation. I am Siddharth Kabade, student ID 125B1F134 from Department of Information Technology at Pimpri Chinchwad College of Engineering, Pune. Today, I will be presenting on a very fundamental yet highly relevant topic in the field of computer networks, that is transmission media, type characteristics, and AI integration in modern networks. In today's world, we send billions of messages, streams, videos, make video calls, and transfer data every single second. But we rarely stop to think, how does all this data actually travel? That's exactly what we are going to explore today. So let's get started. Before we dive in, let me give you a roadmap of what we will covering in this presentation so you know what to expect. We will be beginning with a solid introduction to transmission media, understanding what is it and why it matters. Then we will explore guided media in detail, covering all three types: twisted pair, coaxial, and fiber optics cable. After that, we will do characteristic comparison of all guided media side by side. Then we move unguided media, radio waves, microwaves, and infrared. Following that, we will study switching techniques, circuit switching, and packet switching. Then switching device, hub, switch, router, and bridge. The most modern and exciting part is AI and modern technology in transmission networks. Then real-world example showing how all of this is applied today. And finally, a conclusion and reference. This is going to be a journey from the basic to cutting-edge technology. Let's begin. Introduction to transmission media. Let's start from very foundation. What is transmission media? Transmission media is defined as the physical path or channel through which a data or information travels from a sender to receiver in a communication system. Now let me give you a simple analogy to understand this better. Imagine you want to send a letter to your friend. You need some kind of path, maybe a road, a postal system, or even an email over the internet. Similarly, in a computer networks, data needs a medium, a path to travel. This that medium is called transmission media. Now, transmission media is broadly divided into major categories. The first is guided media and second is unguided media. Guided media, also called wired or bounded media. In guided media, the data travels through a physical cable or a wire. The cable acts as guide for that data signal. Hence the name guided. Example: it includes twisted pair cables, coaxial cables, and fiber optics cable. Key features are high security, less interference, and reliable speed. These are used in wired network connection, local area networks or LANs, and telephone lines. The second is unguided media. Unguided media, also called wireless or unbounded media. Here, data travels as electromagnetic waves through the air. No physical cable is required. Example include radio waves, microwaves, and infrared. These are used in Wi-Fi, Bluetooth, satellite communication, and 5G networks. Now the question is, why do we need to study transmission media? Because the choice of transmission media directly affects the speed, cost, distance, and reliability of your entire network. A wrong choice of media can result in a slow networks, high cost, or poor connectivity. That is why understanding each type of critical for any IT or network engineering. Guided media and its types. Now let's go to deep into guided media. As I mentioned, there are three main types. Let me explain each one in details. Type 1: Twisted pair cable. This is the most common and oldest type of guided media. It consists of two insulated copper wire twisted together in a spiral pattern. Now you make Now you might ask, why twisted? The twisting is done specifically to reduce electromagnetic interference from nearby cables and electrical equipment. When two wires get twisted together, the interference they experience cancel out. This is based on simple physical principle. There are two subtypes of twisted pair cable: UTP and STP. UTP means unshielded twisted pair and STP means shielded twisted pair. In UTP, there is no extra shielding and cheaper, used in most expensive and home lens. And STP means an extra metallic shield for better protection against interference. It is the cheapest and most widely used transmission media. You can find it in telephone lines, Ethernet, LAN cable, and DSL internet connection. The latest version, Category 6 or Cat 6, can support speed up to 1 Gbps. Type 2, Coaxial cable. Coaxial cable has more structured. It has a central copper conductor surrounded by insulating layer, then a metallic mesh shield, and finally an outer plastic jacket. This layer structure can give it much better bandwidth and noise resistance compared to twisted pair. The name coaxial comes from the fact that the inner conductor and the outer shield share the same axis. It supports speed up to 10 Gbps and can carry single over longer distance without significant loss. It is used in cable TV connection, broadband, internet, and CCTV system. You have probably seen the thick black cables used for your home cable TV connection. That is coaxial cable. Our third type is fiber optic cable. This is the most advanced and high performance guided media available today. Instead of electrical signal, fiber optics cable tra- transmit data as pulse of light using either laser light or LED light through a very thin strand of glass or plastic called the optical fiber. Since light travels approximately 3 lakhs km per second, fiber optics provide extremely high speed, up to 10 plus terabytes speed per second. This is thousands of times faster than copper cables. It is also completely immune to electromagnetic interference since light is not affected by electrical or a magnetic field. It can carry data over a very long distance, even thousands of kilometers with a very little signal loss. The downside, it expensive and difficult to install, requires skilled techniques and special spelling equipment. It is used in internet backbone, infrastructure, cables, hospital networks, and data centers. Guided media characteristic comparison. Now let's compare all three guided media side by side. In terms of speed, twisted pair gives up to 1 Gbps, coaxial up to 10 Gbps, and fiber optics over 100 Tbps. For cost, twisted pair is very cheap, coaxial is moderate, and fiber optics is expensive. For distance, twisted pair cover around 100 meters, coaxial around 500 meters, while fiber optics can cover kilometers. For interference, twisted pair has a high interference, coaxial has a low, and fiber optics has absolutely none. And installation, twisted pair is very easy to install, coaxial is moderate, and fiber optics is difficult due to precision requirements. So, the choice of cable depends entirely on the use case, speed needed, distance, and budget. Unguided media, types and characteristics. Moving on to unguided media, these transmit data wirelessly through electromagnetic waves. There are three types: radio waves, microwaves, and infrared waves. Radio waves frequency range of 3 kHz to 1 GHz. They are omnidirectional, can passes through walls and travels a long distance, usually in Wi-Fi, Bluetooth, and AM/FM radio. Microwaves. Microwave frequency range of 1 GHz to 300 GHz. They can travel in straight lines and require line of sight between transmitter and receiver. They are directional and used in mobile networks and satellite TV. Infrared. Frequency range of 300 GHz to 400 GHz. These have very short range, cannot passes through walls, but are low cost and easy to use. You can see them every day in TV remotes and short range devices. Now let's talk about switching. How data is routed throughout a network. Circuit switching. A dedicated path is reserved before communication begins and held for the entire session. Bandwidth is a guaranteed throughout, but resources are wasted when ideal. The classic example is traditional telephone calls. Think of it like booking a private road. It's your alone even if you are not using it. Packet switching. Data is broken into small independent packets. Each packet may take a different route and it's resemble at a destination. This makes efficient use of network resources. The internet, email, and video streaming all use packet switching. Think of it like multiple vehicles sharing the same highway, flexible and efficient. This is where things get really exciting. The role of artificial intelligence in transmission media. AI powered network optimization. Companies like Google and Cisco use AI to dynamically select the best data path in a real time, atomically reducing latency and network. Predictive maintenance in fiber optics. Machine learning of models continuously analyze signal degradation in fiber cables and can predict failures, however, before they actually occur, preventing downtime. AI beamforming in 5G. 5G networks use AI to precisely directly microwave signal towards each individual device rather than broadcasting in all directions. This massively improves speed and efficiency. Software-defined network for SDN. AI can control switching and routing through software instead of hardware, making entire network intelligent and flexible. Real-world modern example. Let's connect everything to real-world application. Google Fiber cables. Google owns thousands of kilometers of fiber cable optics under undersea cables connection across the global, and these are AI modern 24/7 for fault detection. Starlink by SpaceX uses unguided satellite transmission combination with AI-based steering to deliver high-speed internet to any location on Earth, even remote areas. Smart Wi-Fi routers. Modern home routers use AI to automatically switch between 2.4 GHz and 5 GHz bands based on real-time networks uses. Hospital networks. Fiber optics media is used in hospital to ensure zero deadly transmission for a critical data like MRI and X-ray images, where even a millisecond delay can matter. Conclusion. To summarize, transmission media is a physical foundation of all modern communication. Guided media provides high-speed, secure wired connectivity. Unguided media enables wireless communication for your home to satellite. Switching techniques efficiently route data across networks and modern portability. Artificial intelligence is now deeply integrated into this system, making networks smarter, faster, and more reliable than even before. You can see the reference book that I used to gain knowledge about this topic. That brings me to end of my presentation. I hope this give a comprehensive view of transmission media and its evolution with AI. I am happy to take any questions. Thank you so much for your time and attention.